Welcome you guys. Welcome to the Fluid Power Engineering class. Myself Anand Poddar, Department of Mechanical Engineering. In today's class, we will be learning on the hydraulic circuit. In today's class, we will be discussing on the basics of hydraulic circuit, that is the single acting hydraulic circuit. Now before I begin with the hydraulic circuit, first I would like to tell you the meaning of hydraulic circuits. In hydraulic circuits, in the previous class what we learned about the hydraulic components like a pump, filters, the valves. If you arrange these valves, these components in a very systematic way, and when we organize in such a way that at the end we will be getting some outcome or we will be taking out some of the task. Now in a single acting hydraulic circuit, the meaning of single acting hydraulic circuit is the forward stroke of the piston or the rod is by the means of the pump force or the pump pressure, and the retracement of the rod, that is the return stroke of the rod, is by the spring force. Whereas in case of double acting cylinder, the forward stroke as well as the return stroke is by the means of the pump pressure. So let us first, in single acting hydraulic circuit, first we will discuss the components of this hydraulic circuit, and then we will start with their functions, and then we will begin with how this circuit works. Now first one is, I will start from the bottom first. Now at the last what you can see is this one is called as a reservoir, or in roughly you can say is that the tank, and then we have the filter over here, and then the heart of the circuit, that is the pump we have, and then this is the pressure relief valve, and this is a directional control valve, and this is an actuator like cylinder fitted with a spring. Now I will start with the functions of it. Now the function of the reservoir is to store the fluid at a higher pressure. Filter function is to filter it. The pump is, the major three functions happens in the pump. One is a suction of the fluid, and the second one is carrying that fluid at a high pressure, and then last one is delivering the fluid at a high pressure. And then we have the pressure relief valve. The name itself defines its meaning. It's gonna relieve the pressure from the hydraulic circuit. The purpose of providing this pressure relief valve is to maintain the pressure of this hydraulic circuit within the limit. If the pressure exceeds the beyond the limit, this pressure relief valve get opened up, and by doing that we will be relieving, or we will be safeguarding this hydraulic circuit. And then what we have is, this is again the major part of your hydraulic circuit. This is what we called as the directional control valve, and very specific, it is called as 3/2 directional control valve. What is this 3 indicating is, there are 3 ports. What are those? One is P is the pump flow, and A is to the actuator level, and T is the tank. Okay, and this 2 indicating this is a 2 positional, in the sense we have got 2 position. We can call this as a left envelope, and this is what we call as a right envelope. And then what we have is, we have the actuator which is fitted with spring inside it. Okay, now we will start with how this hydraulic circuit works. Now before I'll start with this working, let me tell you about this directional control valve in detail. Now what we have in this direction control valve is, see, we have 3 ports as I told you. We have a pump flow, and we have to the actuator level, and can you see this arrow mark which is there in the left envelope, and the meaning of this is closed one. When we write like this kind in a direction control valve, that means that it is a closed one, there is no flow further. Okay, now we'll start with the working. Now as soon as your pump start working, as soon as the suction begins, whatever the fluid which is there in the reservoir, that will be sucked from the reservoir, and it will go to the filter. The function of the filter is to clear all the dirt or all unwanted materials from the fluid, and it is taken to where? It is taken to the pump. Now the fluid, after entering to the pump, the pressure of the fluid is going to increase it. It comes with a less pressure, but as soon as it entered to the pump, the pressure is going to increase it. So here we have the pressurized fluid. Now once it enters over here, okay, now it is a junction. Now fluid is over here. This is all what we can see is that these are all the pipes through which the fluid is going to flow. Now once the fluid enters at this point, now fluid has two way to go now, like it is junction. Either the fluid can go in this direction or the fluid can move in this direction. Now let me consider this direction first. Will the fluid will going to move in this direction? What is this called as? This is called as pressure relief valve, and it is what? It is subjected to the spring pressure. Okay, when the fluid pressure comes, and if the fluid pressure is less than the spring force, it is not going to open up, means it is like a barrier for us. So this pressure relief valve will get open up only when the pressure of the fluid is more than the spring pressure. Then only this will get opened up and the fluid is going to collect it back to the reservoir. So right now whatever the pressure comes from the pump, that pressure is less than this, so it will not get opened up, means the flow is not going to move in this direction. The fluid is not going to move in this direction. The only way or only the direction which is available for the fluid is to move in the upward direction. Fine. Now once it enters to this direction, okay, now we will be discussing in two parts now. What happens when we actuate the direction control valve to the right side, and when we actuate the direction control valve into the right side, what happens actually now? Now let me first tell you about the right hand side of the DCV. Right hand side DCV means what? The pump flow is directly connected to where it is connected. Now what it means, I have already told you, this indicates that this is a closed one, means there is the flow, even though the flow is coming from the pump now, but there is a no one, it is like a closed one. So what happens? There is the developing of back pressure. So back pressure start developing because there is no any way for the fluid to pass it out. So what happens is the fluid start accumulating, and you have this pipeline will experiences a back pressure. So what happens? The pressure inside this pipeline or in the flow will gonna increases. So this start increasing it. As it start developing more and more pressure, it will crosses the pressure of this. Let us assume that it has, I have set it for say or for example 150 megapascal, and if the pressure which is developing over here is, it is crossing this. If it comes more than 150, let us assume that if it is developed at 155 megapascal, at that time this pressure relief valve get opened up, and whatever the excess flow which is coming, that all we gonna collect it into the reservoir. So by providing this pressure relief valve, we are providing a safety for this hydraulic circuit. Even though there is no flow, there is no any function is happening, but because of the pressure relief valve what we have provided in the hydraulic circuit, it has provided the safeguard for this hydraulic circuit. Now this is what I have discussed to the right hand side of the DCV. Now let me tell you about when we switch it to the left envelope of the direction control valve. As I told you, this is 3/2. What is the meaning of 3/2? We have a 3 ports here. This is this one and this one, okay, and 2 indicating there are 2 positional. Clear? Now when I switch it my DCV to the right hand side of the DCV, okay, now what happens? This flow is connected to this. You have to feel it, you have to imagine like whatever the pump flow which is coming over here, that is directly connected to this. Okay, so now pump flow is coming, means this you can assume it, this you can imagine over here. The whole setup is going to come like this. So whatever the pump flow which is coming from the pump, that is all taken to this, and see the arrow mark which is here. This arrow mark is going straight way. That means whatever the pump flow is there, that is already connecting to this. So pump flow, the pressure of the fluid which is going to come from this, and it is directly connected to this. Now let me tell you about after this what will happen. Now whatever the fluid which is coming over here, so that all will be taken to move inside the cylinder. Means all the fluid which is going to come over here, pressurize the fluid. Now as soon as it enters to the cylinder, it start exerting a pressure on it. It start exerting a pressure on this piston rod or piston surface. As a result, what happens is, if the pressure is more than the spring pressure, whatever the fluid which is coming here, if the pressure of that fluid is more than the spring pressure, what happens is your spring start compressing it. Means what? Whatever the load you want to keep it on this rod. Let us assume that I am going to keep some load over here. Okay. Now as because of the pressure of the fluid, it start compressing the spring. As a result, your spring start compressing it and your piston start moving towards to the right hand side, and this rod is going to move in this direction. So which stroke it is? This is called as a forward stroke. This is called as a forward stroke. In forward stroke, the forward stroke happens only because of the pressure of the fluid. Okay. So as soon as the piston reaches at one end, let us assume that this is the last position of the piston. Now piston is over here now, and your spring is compressed like this, and your rod is like somewhere like this position. So this is what your forward stroke. Now when we want the retraction stroke or in the backward stroke, what we need to do is we need to again switch it from the right envelope to the left envelope. What happens in the left envelope? In left envelope, you don't need to send any fluid to this direction. Okay, since it is a closed one, so no any flow is going to pass it over here. Now the return stroke happens only because of the spring pressure or the spring force. Now whatever the spring which is forcing this, whatever the fluid which is already you have collected over here, that all the fluid is going to come and see what is the direction over here. This all the fluid is going to come and we are going to collect it back to the reservoir. So this is how your single acting hydraulic circuit works. I'll just brush it in 1 minute. So first the reservoir, then we have a filter, then we have a pump. This is a pressure relief valve, direction control valve, actuator, cylinder fitted with a spring and a rod. Now how it works? We gonna learn in two parts. What happens when we switch it to the right hand side? What happens when we switch it to the right hand side? When we switch it to the right hand side, what happens is whatever the fluid which is going to come from the pump, which is connected to back to this, so all the fluid which is directing towards the A means which is going to move in this direction. Now this is nothing but A only. Okay. Now all the fluid which is going to come from the pump, it is directed and it is directed back to enter into the cylinder, where it is going to pressurizes the piston, and because of the pressure of the fluid, it start compressing the spring and we will be achieving the forward stroke. In return stroke, we need to switch it from the left to the right. Okay. As a result, what happens, even though you are pumping it, the fluid is not going to enter to this end. It is a closed one. Okay. Whatever the fluid which is, even though it is coming up, that all comes to the tank via this pressure relief valve, and whatever the fluid which is collected over here, that all the fluid is going to come back to the tank, and the return stroke happens because of the spring force. This is how your single acting hydraulic circuit works.